Hello and welcome to today's question of the day from the actual IPMAT Indore 2024 paper QA MCQ section. Well, the purpose of this series is to help you understand how to choose the right set of questions in the paper and also help you understand the best methods to solve the questions that have come in the 2024 paper. So today's question is based on progressions and logarithm. And before I go ahead and solve the question, I'll read the question and try to understand whether I should have solved this question in the first go, or whether I should have tried this question in the second round, or whether I should have completely left this question in the exam. And then obviously we'll go through the solution and understand how this question could have been solved in the best possible way. So the question is, the terms of a geometric progression are real and positive. If the pth term of the progression is q and the qth term is p, then the logarithm of the first term is. Well, the data is quite simple. The options appear to be a little complicated. So it feels like I should leave this question for now. However, because the data given is very simple, I'll just see if I can write the equations and is there anything which strikes me to solve these questions quickly. Okay, so the pth term is q, so the value is q and that is nothing but the pth term, so that is a into r raised to the power p minus 1, right? This is how you define the nth term in a geometric progression. Similarly, p would be equal to a into r raised to the power q minus 1 because qth term is p, so q minus 1. I realized the equations that I had to write were very simple, but we had to find the logarithm of the first term. Will I be able to solve these two equations and get an equation for a, the first term? If I take the ratio, a will in fact get cancelled out and I'll get a relation for r. However, if I had to cancel out the r, I would have to make the powers of r in both the equations equal, and then I could cancel out the r, right, by taking the ratio. So if you just see, both the equations have different powers of r, and to make the power of r equal, I think we can raise both the equations with the other power. Just like we solve simultaneous equations, if a has a coefficient of 2 in one equation and coefficient of 3 in the other, we multiply both the equations by 3 and 2 respectively. Here this is a multiplicative equation and there are powers involved, so we will raise both the equations by the other power. So raising the first equation by power q minus 1, this will become q raised to the power q minus 1 equal to a will also get raised to the power q minus 1 into r raised to the power p minus 1 into q minus 1. Because r raised to the power p minus 1, the whole raised to the power q minus 1, the powers will get multiplied. Similarly, the second equation would become p raised to the power p minus 1 equals a raised to the power p minus 1 into r raised to the power again p minus 1 into q minus 1, right? Because q minus 1, the whole raised to the power p minus 1, the powers will get multiplied. Now if you take the ratio of both these equations, you will simply get q upon q minus 1, the whole divided by p upon p raised to the power p minus 1, and on the RHS, r raised to p minus 1 q minus 1 will get cancelled when I take the ratio, and a will have a net power a raised to q minus 1, the whole divided by a raised to p minus 1, that will become a raised to q minus 1 minus p, and minus of minus 1 will become plus 1, because when the powers are in division, you take the difference of the two powers. So minus 1 plus 1 will get cancelled, and on the RHS you will simply have a raised to q minus p. Okay, I wanted the log of a. So that's very simple now. I think I'll take the log of both the sides of the equation, and I think I should be able to get the expression for log of a. So taking log on both the sides, and I'm writing LHS on the RHS, RHS on the LHS. So that will become q minus p times log of a. The power comes in multiplication, and on the RHS, it will become log of q raised to q minus 1, the whole divided by p raised to p minus 1. Now as we know, when there's a division involved or when there's a fraction in logarithm, we can split the log as log of the numerator minus the log of the denominator, and the powers will come out in multiplication. So I'll skip a step and I'll directly write q minus 1 times log of q minus p minus 1 times log of p, right? This is what we get. I'll just erase the initial working to get more space to complete my solving. So I'm erasing this working, the initial working that we had, and yeah, basically make space. So if you've not noted that down, you could just go back and note that down. So continuing from here, okay, what we get is if I keep the log a on the LHS, that gives me q minus, and I keep looking at the options also. All the options have 1 minus q, 1 minus p, and the denominators have p minus q. So I think everything is going to get multiplied by minus 1. The order will get reversed. See here, each term is q minus 1, p minus 1, and on the LHS the order is q minus p. If I reverse the order of difference on LHS and RHS for each term, the equation would remain the same. So I can directly say this would become 1 minus q log of q minus 1 minus p log of p, the whole divided by, instead of q minus p, it will become p minus q. And therefore, I'll just check if there's an option like this. Log of a would be equal to 1 minus q times log q minus 1 minus p times log p upon p minus q. There's an option which looks exactly like this. Hence, the answer to this question would be option B. That is 1 minus q times log q minus 1 minus p times log p upon the whole upon p minus q. Now, after solving this, you have to evaluate whether you could have gone through this exercise, or whether you could have done this in the exam, and whether you should have solved this question or not. If I were taking the test, I would have tried this question, because I know if I just keep working quickly, there was just mechanical solving involved. But if I go through these steps, I could have solved this question in less than 2 minutes. So therefore, I would have attempted this question.